The final topic that we will be covering in this chapter is the distinction between basic and applied science, and how scientific findings are officially communicated. We talked about how some science is descriptive and some science is hypothesis based. Another way that we can slice the science pie into two different categories is basic science versus applied science, both of which are relevant to the overall broader study of environmental science. The goal of basic science is to expand knowledge without a strict focus on how that knowledge might be used in applications that solve problems. Applied science, on the other hand, is focused on solving immediate real world problems. While some people's first instinct upon hearing this might be to say that for this reason, basic science is less useful than applied science, both are very important. And that's because although basic science does not always have an immediate use in mind for the knowledge it is pursuing, the information that we get from basic science often leads to future solutions to problems. Um, and applied science actually relies really heavily on the information that comes out of basic science endeavors. So, for example, a well known example of basic science was the discovery of the chemical structure of DNA molecules way back in the early 1950s. And when this discovery was made, there were no applications for this information. There were no ways that it could be used to solve real problems. But decades later, applied science was able to take that information about chemical structure of DNA and use it as the basis for genetically modifying commercially important crop plants to make them more resistant to pests. So this solves a real world problem, but it relies on basic science to do so. Regardless of whether a scientific study is basic or applied, or descriptive or hypothesis based, there is a universal standard for how scientific knowledge gets communicated to others in the field, and that is through a process of peer review and publication in a scientific journal. So these journals are collections of research on a particular subject matter, and there's dozens of scientific journals that are pertinent to the environmental sciences, and I've included just a small handful of them here on the screen. But to get your research published in one of these journals, it must first undergo a process by which other well qualified scientists in that same field, so in other words, your peers as a scientist, must review that research and critique it, ultimately judging whether it's worthy of entering one of these publications. So these peer reviewers are making sure that the research is original, that it's significant, that it was conducted ethically, and that it meets all of the standards necessary to be considered a high quality piece of science. This is the process for ensuring that the scientific knowledge that gets published and communicated out into the broader world is reliable. So, knowing this, when you are independently evaluating sources of information, it's important to ask yourself, did this information come from a reliable source that has undergone serious scrutiny and peer review? Are these conclusions accepted by the scientific community? Is the information credible, and should I accept it as significant when I'm building my position on a particular scientific issue?